How do you make the CO2 as a molecule useful?
Carbon dioxide is what we call a dead molecule. So by itself, it can't really do anything.
SAF is 4 to 5 to 10 times more expensive than kerosene, even with what's happening in Hormuz. So getting the cost down is the key thing.
We're not underwriting molecule, we're underwriting the process, because
You have built a facility that relies on an input, you're paying for that. There is no world where CO2 is free once you've built it.
Develop a whole industry of assurance to make sure that when somebody claims they've disposed of CO2 in conjunction with an EOR operation, it's actually done what they've said it's done and stayed there.
A ton of CO2, put it on the capital stack, wrap it with insurance or protection, and turn it into cash flow and fist bump.
We had our 100-ton per year demonstration plant just launched 2 weeks ago, so it's feeling very fresh.
Hi, I'm so happy to see people are enjoying their breakfast, enjoying the AC on this such a hot day. When I came in this morning, I was worried, but I came down to this outside, everyone would love it. And then I do want to know, how long does it take for you to arrive in London Climate Week this time? If people can just quickly vote. I live here. Same. Over 10 hours. Wow, I think Alex is from Canada. California. Welcome. Thanks everyone for joining us. Oh, there's another over 10. Oh yeah, California. It's a fruit check-in. If carbon to value were a fruit right now, what fruit would it be? And when people are thinking, I'm just going to quickly introduce Nilay. So Nilay is a professor of Imperial College. And maybe, Nilay, you want to say a few sentences about...
Definitely. Hi, everyone. Sorry I can't be with you today. But my name is Nilay Shah. I'm a professor in the Chemical Engineering Department at Imperial College. And I'm also the co-founder of a company called Zero Petroleum, which makes synthetic fuels from hydrogen carbon dioxide. And we make fuels for motorsport, aviation, and other applications as well.
I have to say, when I'm advertising for this event, a lot of people, of course, knows Professor Myles and his great work, but also a lot of people are interested in Nilay coming as well. They were like, oh, I used to work with him. He's my professor at university. So a lot of founders that I know and admire actually work with both of you, I guess. So for the questions, people have voted. Pineapple is a key theme I can see. I would love to know why.
I think when they first discovered pineapples, certainly in its early days, it was worth much more than its weight in gold.
Really? Learn something new every day. This is today's flow. Maybe I need to give myself an introduction. So I used to be an investment banker. I work in structured finance. We have a lot of jargons, a lot of acronyms. And then I move over to the team to help climate tech companies raise money. Again, a lot of acronyms, which is more difficult for me because they're all like scientists talking to scientists. So I always start our session to talk about the science. And I'm going to pass it over to Nilay as well first to talk about from molecule to market. The thing that I'm very, very interested in and curious about is if CO2 as a molecule can provide value, what is the story and what are many different ways we can do that? Of course, today we're going to focus on the synthetic fuel aspects. So please, Nilay.
Great, thank you. So it's probably surprising for you to hear that sometimes we actually run out of carbon dioxide. And this actually happened recently in the UK. So we do currently use carbon dioxide. And strangely enough, the government had to incentivize a bioethanol plant to restart production, not because we need bioethanol. We actually have more than enough bioethanol coming from the US and Brazil, but because CO2 was a byproduct which is needed in the downstream industries. So we've been using CO2 for a long time, but it's only in very specific applications at the moment. And of course, the excitement we have around CCU is, in principle, we can make a lot of different things out of carbon dioxide. Not so much because of the oxygen in it, but because of the carbon. Probably 80+% of things we use every day have some carbon in it. So carbon dioxide is cheap, and we can make lots of things that are useful out of it. So that's an important message. However, the big challenge is carbon dioxide is what we call a dead molecule. So by itself, it can't really do anything. And so when we want to use it, we have to combine it with something highly reactive. Two good examples are hydrogen, which you're all familiar with, or something called epoxides, which probably you're less familiar with, but epoxides are a very important building block in the chemical industry. Using those kinds of reactive molecules, the next step is try to find some opportunistic niches where we can build learning, know-how, market, IP, and of course scaling and cost reductions. So one good example of a niche market which could grow very quickly is something called polycarbonate polyols. So polycarbonate polyols are a family of polymers, and they incorporate carbon dioxide in their backbone, and they can be used to replace similar molecules at lower cost and lower carbon footprint. So this is a really exciting opportunity because you're not in the language of trade-offs. Because one thing that's always a challenge in sustainability is we often use the language of trade-offs. But these polycarbonate polyols, in principle, can outcompete fossil equivalents. And they go into products like polyurethanes, which in turn go into products like mattresses or sporting goods or a wide range of other things. And these are being commercialized today. So one company is Covestro in Germany, huge company. It's run out of fire. But also there's an exciting company in the UK called Econic Technology, actually founded by Myles' colleague, Charlotte Williams. They're developing this technology very quickly. So that's one example. And I'll come back to that one in a minute. Another good example of where we need carbon dioxide is the area where I have particular expertise, which is in...
I think Nilay gave us a really good map about like what kind of value like a CO2 molecule can create. And maybe it's time to welcome Myles. Please join us on the stage. Basically, Myles, I have the great honor to welcome Myles to this Breakfast Club. I think it's the most high-profile professor that I've ever talked to. Apparently, he's been in the climate space for the past 20 years and who's also a contributor of the IPCC documents. And then, so we're going to pass on to you to help us decode what Nilay just said and what he has left to you, the one example, and then help us, basically.
So thank you, and good morning, everybody. And it's actually, I regret to say, rather more than 20 years I've been working in this space. But and it's also slightly unfair because Nilay, I was hoping Nilay would be here because I wanted to argue with him. You have two professors. Our job as academics is to argue with each other because that way people get some ideas. I want to start off by asking you a question. In scenarios where we meet the goals of the Paris Agreement, what do you think the main use of carbon dioxide in 2050 will be? And please be open-minded. In the scenarios, so in the IPCC scenarios where we meet the goals, what do you think the main use globally, by ton, not necessarily? Nilay is back. So, okay, good, Nilay, because I'm trying to be outrageous. I've asked a question. I'll leave them thinking about it and go back to you.
Thanks for stepping in. So I think where I got to was saying that polycarbonate polyols can go into products like mattresses and sporting goods. And we have companies like Covestro and Econic Technologies that are commercializing that. A very different example is what we call e-SAF or e-fuels. If we make aviation fuel from carbon dioxide, it's expensive today, I'll be honest. On the other hand, it's eventually a large volume business, currently only mandated at relatively low volumes, and that helps bootstrap the industry. So there's only a gradual influence on cost because as we ramp up the mandate, we hope that the learning by doing and the scaling efficiencies compensate for the increased costs. And the other thing we found in our analysis is aviation has a lot of fixed costs. So the variable cost of the fuel doesn't change the ticket price as much as you might think. And finally, there are very few solutions to how we fly or indeed ship goods sustainably. And this is one. I'm sure Myles will give you a couple of other alternative ways of having zero carbon aviation. So coming back to my first example, a key there is to get low-cost epoxides, which are the reactive molecules, and good access to markets. It's a B2B product, and so the end user needs to be a strong brand with a strong sustainability strategy so that their offering can displace the alternative. If we look at aviation fuels, the key is going to be low-cost energy for the hydrogen that you need to make the fuel, and access to markets with strong policy support. And at the moment, those two don't align so well. So where we've got low-cost energy are not the countries where we have strong policy support. So you might need to look at certification schemes and book and claim methods to look for eligibility. So both of those pathways, which are really good examples, polymers and fuels, they currently need a very high level of technical competence. The plus is you've got good moats for developers and investors. The minus is, of course, that might slow down deployment. So my big question for you is, these two, I think, will continue on their momentum, these two niches of specialty polymers and aviation fuels. But there's a lot of debate at the moment for the EU and the UK and lobbying to be less ambitious on its mandates for fuels. And so how quickly those two will go is a bit of a question. So my question overall is, how do we break out of niches and ensure wider deployment of carbon dioxide into everyday products? An example would be, standard polymers like polyethylene, polypropylene, which you can make today, but, which would be quite expensive. And in a world where we worry a lot about cost of living and inflation, how might this happen? And we have some ideas like using public procurement and gradually winding up mandates and so on. But I'm very curious for you to think about that big question of, we may be successful in niche, we just get stuck there. How can we use the know-how to break out of those niches? So thanks very much for your attention, and I'll pass over to Myles now.
Okay, so Nilay, I'm glad you can hear us, because I was interested in the room's view, and you can join in this one, as to what the main, in terms of tons, use of carbon dioxide will be in 2050 in scenarios that meet the goals of the Paris Climate Agreement. Does anybody want to make a suggestion? Aviation, use of carbon dioxide globally, use of captured carbon dioxide globally. So Nilay's given us a couple of examples: production of SAF and production of polymers. What do I think? Production of fizzy drinks has been thrown out there. What do I think, as a climate scientist who's also studied the scenarios of the Intergovernmental Panel on Climate Change that actually deliver the goals of the Paris Climate Agreement, I'm almost completely confident. You should be careful of any academic who says I'm completely confident, but I'm almost completely confident I do know what the answer is, and it's none of those three. No? Yes. How much do you think oil and gas use declines between now and 2050, usage in terms of tons of CO2 generated in scenarios that meet the goals of the Paris Climate Agreement? Now, it doesn't go up, but it does go down. Absolutely. We do have to use less. We can't just bury the lot. Well, in some people's fantasies, they might think you can, but don't believe them. But does anybody know how much it goes down between now and net zero in scenarios that actually meet the goals of the Paris Climate Agreement? Gas goes down by about that amount, oil by a bit more, oil by maybe 50%. So there's still an awful lot of oil and an awful lot of gas in use. This is a world, so you may think, well, how do we achieve net zero? Well, the answer is we're storing a lot of CO2 back underground. We're injecting CO2 at the same rate that we're generating it from continuing to burn fossil fuels at the date of geological net zero. That's a moment in time. And after that, in the scenarios, we continue downwards in our use of, although not all the way to zero, and we continue upwards in our injection, so we actually go net negative, and that brings temperatures back down again. But at the point of net zero, we've got this broad global balance of gigaton scale production of CO2 on the one hand from continued use of fossil fuels and CO2 storage from, so storage of captured CO2. Now, some of that CO2 might be captured at point sources, CCS and so on, but an awful lot of it by then will be being recaptured from the atmosphere. Because the scenarios work it out and realize that many of our existing uses of CO2 no longer make sense in this world because you've got a relatively high effective carbon price through whatever climate policies you've got. And so we've moved on from a lot of we've electrified road transport and so on, done all that sort of thing. But, industries like aviation, cement production, steel, and so on are still using fossil fuels, and their CO2 would have to be either captured at source, in the case of steel and cement, or recaptured from the atmosphere in the case of aviation. The vast bulk of it would be quite logically used, if it's allowed, perhaps I should say, if it's allowed, used for production of the fossil fuels we're still using.
Can I ask a question there?
So I knew this. This is probably the most outrageous thing you've heard in London Climate Action Week. So there you go. You've got an answer to that question now. You didn't have it earlier, but I think it's true. But tell me why it's not.
But why would you be spending on each unit more to get the enhanced oil recovery when we would just purely use Saudi fields, surely, if we're down to 50% production? So why are we using expensive fields that require enhanced oil recovery when we've got half the production? Why are we using high marginal cost fields?
Because if you've got to get rid of the CO2 anyway, as I say, in scenarios that meet the Paris Agreement, assuming that we are in a scenario that's meeting the goals of the Paris Climate Agreement, where we have to get rid of this CO2, what are we going to do with it? At the moment, in Europe, you're only allowed to stick it into pristine saline aquifers. Will the rest of the world insist on that? And certainly not in the Middle East. They'll put it anywhere. They'll put it into depleted fields, and increasingly it'll be put into not quite depleted fields and used to flush out whatever's left. So, and this is a massive volume market. It's the remaining use of oil and gas in the 2050s is multi-gigaton scale. It's not, and if you're getting rid of CO2 at the same rate, the totally logical thing to do would be to make sure you're injecting it at the same rate you're taking the oil and gas out and using it. Well, probably a lot of it would be coming from direct air capture if it's not being generated in the right places. Some of it, in the Middle East, for example, they've got embarrassing amounts of CO2 being generated from point sources. And so they'll hopefully capture that first. And then later on, we'll be likely needing to use direct air capture to do that. And yes, there'll be lots of other uses of CO2 as well. But a question I think we need to ask is, for the Sustainable Aviation Challenge, if we're capturing CO2 from the atmosphere, you've captured CO2 from the atmosphere, you've then got a choice of what to do with it. You can either add a lot of renewable energy to turn it into a sustainable aviation fuel at quite a high cost, or you can stick it underground in an EOR field at essentially no cost and burn kerosene. And both activities are, as far as the climate is concerned, equivalent. So which one are we going to do? Well, the one that costs half as much, probably, okay, unless it's banned. Now, it may be banned, which is why I can say I'm almost sure this will happen, because I'm not quite sure what our governments will do between now and then. And at the moment, our governments seem to be intent on making net zero as expensive as possible, possibly because they don't really want to do it, and therefore they want to make it more expensive. But I mean, the cheapest way of doing it is almost certainly this kind of balance. I'm sure you disagree with lots of this, but that's fine. That's the point of a breakfast club.
John has a question.
Sorry, I actually completely agree with the scenario painted out. I understand the logic that's getting you there. My question is, if oil and gas use is declined by 20 to 30%, but then we are counterbalancing all that use by capturing CO2 and pumping it down, what is that actual volume of CO2? How much is that cost? What percentage of GDP would that be?
Oh, yeah.
There's just direct air capture in that scenario.
I'm telling you about
10%?
No. The cost of CO2 disposal as an industry in scenarios that meet the goals of the Paris Agreement. So I'm stressing this is but in least cost scenarios
to meet the goals. So these are scenarios where you allow technology, you allow the model to work out the cheapest way of doing things. Because fossil fuels remain so competitive for so many applications, Now, of course, these scenarios might be wrong. You find that you end up with a scenario where we're injecting CO2 at multiple billion tons. I can't tell you how many, but it'll be in the billions of tons per year. So that's comparable to today's gas industry.
It'd be tens of billions of tons.
No,
right?
I would say billions rather than tens of billions. I mean, at the moment we generate CO2 at 40 billion tons per year, but a lot of that's coal. Okay, and that's one thing which doesn't make sense in these scenarios. So that's phased out. So we're left with the oil and gas contribution.
But a ton of oil burning doesn't produce a ton of CO2, right? It's not a one-to-one.
No, please don't test me on the conversion factors. You can do them. I believe the scenario builders have done the conversions correctly. And what you end up with is of the order of 10 billion tons of CO2. So you've got aggregate oil and gas use roughly like below 20 billion tons of CO2 per year at the moment. That goes down to around 10 billion. So you're looking for of all the 10 billion tons of CO2 per year, but ideally, and in the more plausible scenarios, a bit less than that. And you want to be in that scenario, in that world, because if renewable energy costs continue to come down, we might expect that to be less than. So that's why I'm saying less than 10 billion tons per year. We got to hope that's the result, because I think more than 10 billion tons per year is going to be technically a stretch for.
Even at $100 a ton, that's $1 trillion a year, right?
Yeah. Well, what do we spend on fossil fuels? I mean, so again, if you sort of think of it in that context, if you think of it as just a straight bill that somebody has to pay, then it looks a bit daunting. If you think of it as a percentage on the value of the fossil fuel economy today, I don't know what Brent crude is today, but it's actually a relatively small, significant but not impossible increment on the cost of fossil fuel. So if we added in an obligation to get rid of the CO2, arguably these producers have anyway, because they've all signed up to the Paris Agreement and they say that's what they believe in, then it'll make fossil fuels more expensive. We'll use less of them for sure, but then they will then use the CO2 for EOR. Why not? And that's a genuine question. I mean, maybe you want to argue that we should. But by the way, the reason I think this is important is I think this is a possible future. And nobody's thinking about it. Because, for example, all of the legislation around CO2 disposal, all of the regulation around CO2 disposal, which has mostly been developed in Europe, is targeted at aquifer storage, so injecting CO2 into saline aquifers, or turning CO2 back into rock, or various permanent means of CO2 disposal. It might work to inject it for EOR, and the companies assure us, oh yeah, when we inject it for EOR, it stays there. Do we know? I mean, is anybody checking? That's where we, if this is going to happen in the next 30 years, we need to. Nobody's thinking about that right now.
I think these are all very good intellectual discussions, and thank you so much for bringing that perspective. I need to give context. Half of the room maybe is new to this topic. Some of my friends from banking and investors. I think what you just said is to have a bridge between the imaginary scenario that we have in mind and also how can we build it up to 2050. And that all of them, I don't think there is a black and white or there is anything that's have to be correct or have to be incorrect. And nobody actually would know what's going to happen in 2050, right? Yesterday, I was at the TED Countdown Summit with Tencent and they announced their winners. Maybe Alex actually won yesterday. And then I was like, I sat down, I was like, this guy is coming to my breakfast club. This is great. So one of the things I took away from that conference from the TED is actually there's a way to make carbon removal cheaply and more efficiently, and also with value that we can create, not just the carbon credit or offsetting. And the whole theme of yesterday is exactly that. How can we make a future that's as the same as today, that people can live just as nice as today, or even better, without having to compromise how we live. You have a question?
Your point about humans' wants and needs and wanting better performance, better quality is absolutely. Other point to make, which I agree with Myles on, is about the distribution across the world. Now, you'll see all of these scenarios. I was in the Climate Change Committee doing this and I've set up the whole framework. It will say the cost is 1% of GDP. And for me, that's fundamentally dishonest because it's plus 10%, minus 9%. So there's a big shift between sectors and between economies. So I think you are likely to see, this is why I think this has got a good traction and good grounding. Economies that are fossil fuel economies have to find other ways to create revenue and provide their economies and societies. So if you find a way for it to be done within the economy and society and, propel growth in a sustainable way, I think that's much more likely than saying we're going to shift the whole economy from X to Y, because we know there's a huge amount of winners and losers. Structural change is difficult. We've got stories in the UK, the coal industry, this, that, the other. German reunification, construction went from 3% of GDP to 9% of GDP for 15 years. Just think of the political will to do something like that, of like, if you are going to structurally shift an economy. So I think this is why I would say that the default of saying, actually, this makes sense and we can keep these economies broadly fossil based in a way, a sustainable way with CCS and what you just talked about makes sense to me.
Yeah, I think
Sorry.
No, I think it's we all need to do it step by step, right? Like there's no way just to jump to 2050 from now. And I think it's the right time to do the breakout because you apparently want to discuss and we can move along with the discussion. This is perfect because we actually have the first breakout in your table. You can pick one of the CO2 to value pathway and talk about what is the promise, what is a bottleneck, what makes it hard. Just to continue the discussion you have because we're going to swap around after this. I think everyone has a great discussion just now. Now it's the table swap. Some of the plates you will have an envelope under your plate. So this is a Chinese envelope. Usually we have money inside, but there's no money inside. Once you open it, so you will have a secret mission, which is the question. You can take it to the next table, and then you have a color written on the bottom right, which will show you which table that you are going to go to. So the people who have the red envelope or yellow envelope with you are going to move table to the color that you are going to move to. And the other people stay where they are and welcome the new people. So please shuffle now. Sure, everyone is happy with the new table mix. And then have ordered your delicious breakfast. So I think it's a good time because we talked a lot about theory and also scientists. It's a good time that we make it real and make it bankable. So today I have the honor to have John, who's the CEO and co-founder of Bankable, to join us, and also Olia, who's the investor in Siemens. So please welcome to join us on the stage. It's not a panel discussion, but I think it's better that they would all here to join us. And I've known Olia for quite a while now, and I only got to know John recently, and I find the whole sustainable aviation fuel topic really fascinating. Right? Like, and how do you first come up with the idea of Bankable, and what's the journey been like for you? How do you make the CO2 as a molecule useful?
Yes, it's a really good question. So the first thing to say is that at Bankable we take a completely different approach than a lot of the things we've discussed today. So a lot of the ideas we've discussed today have been like capturing carbon directly and then brute forcing it to more complex molecules through like chemical processes. At Bankable, we're using nature's carbon cycle. And I think it's worth pointing out that the biosphere absorbs something like crazy, like 300 billion tons of carbon dioxide every year. Like what we humans emit is a very small amount of what's just naturally being absorbed and released every year before we were here, right? Photosynthesis is the most efficient way to capture carbon and turn it into other stuff the world has ever seen. And what we do at Bankable is we use the most photosynthetic efficient organism on the planet, which is algae, the little green things that swim around in water. And we find ways to get the carbon products out of those algae much more cheaply. Cost is the main barrier to adoption for all these things. The main barrier of microalgae to fuels is the cost of production. Getting oil out of algae is really expensive, so we found ways to make that cheaper. That's the short of it. How we came to this idea, well, I can't take credit for this. This is my co-founder's, my CTO's idea. My background is actually in nuclear engineering. I did my PhD in fusion and was very, very dispirited by the lack of progress in fusion. And so I switched over to this field. So make of that what you will.
I wanted to know, for people who are outside of carbon, and when you first talk to investor, what is their first question to you? Like, and how's that journey been? How do you make it economically viable?
So if anyone's heard of Algae before, it's only because they heard of yet another algae startup collapsing. If you're on the micro-algae, there is a graveyard of companies out there. And I think the generally first reaction I get when I say to investors we work on micro-algae, it's like an eye roll, deep sigh. But the point I always make is that I'm not an algae person. There's a lot of people within this space who just love the stuff they work on. This is a big problem with technologists, is we love the technology we work on. That's why we work on it. This is why we dedicate our lives to it. But you can't have that approach when you're an investor. You can't have that approach when you're trying to scale something. You have to be quite harsh and realistic about it. I don't like algae. As I said, I'm a mechanical engineer, materials engineer by training. But algae are the most efficient way to do what we're trying to do. And that's what I try to say to investors is, look, I know people have failed, but they failed for this specific reason. They can't get the cost down. We are directly attacking that problem. So if we can convince you that our solution works, there's no reason not to invest. So I think it's actually finding the real pain point that has prevented things happening from before.
What is the bottleneck right now?
For us personally, or for the field?
For the field.
For the field, it's cost. It's how do you get, no one wants to pay more for their jet fuel. No one in the world. SAF is 4 to 5 to 10 times more expensive than kerosene, even with what's happening in Hormuz. So getting the cost down is the key thing.
How about it? And what's expensive about the processes people usually work on?
Yeah, so particularly with microalgae, you grow this big tank full of green stuff. They are, in each milliliter, each like raindrop, you'll have maybe 10 million cells. So these are absolutely minute things. They are very good at absorbing sunlight, very good at making oil. But to actually get that oil out, what you have to do first is like remove them from the water. So you have to dry out these cells, which is very difficult. You then have to break those cells up. You have to like mechanically and chemically like destroy the cells, remove the oil with a solvent. And then the first thing you have to do afterwards is you go back to your tank and regrow the algae. While they're growing themselves, they're not growing oil. So it's very difficult, inefficient batch process. What we do differently is we have genetically engineered them to secrete their oil continuously. So instead of having to sort of kill and extract and do all this stuff, the oil just floats to the surface and then you skim it off the top. So you can see immediately it's a lot cheaper and easier to do. For us, the bottleneck is just getting that working consistently, rapidly, productively. And that's what we're working on at the moment in our lab.
Yeah, I think this is a good time to bring in Olia, because Olia is actually an investor who looked into SAF, sustainable aviation fuel, synthetic aviation fuel, and more than that. From an investor and industrialized, commercialized perspective, tell us about the first time you hear about this and what has changed in the past several years.
I'm part of Siemens Emerging Technologies team. We see ourselves as an industrial partner and investor. And I think what makes CO2 molecule kind of when we see CO2 molecule becoming valuable is when we see, high confidence in being able to operationalize it. So we can identify, potential to sign for it, to integrate it, and take operational risk on it. Okay. Kind of just bridging to what John just said in terms of where we step in. I think, John said about, still experimenting in the lab, right? I think where we tend to come in, and I think previously we came earlier, we came at TRL 4, TRL 5. Now we're coming later at TRL 6, 7, where we have a high confidence that chemistry works, conversion works, but the system is not yet industrial. So basically we're not underwriting molecule, we're underwriting the process, because as an industrial investor, as an industrial partner, we're looking for the system that has demonstrated kind of stable enough process for continuous kind of number of operating hours, like 1,000. That's where we see we start understanding that the system we start understanding how it behaves, how the process behaves, how the system behaves. And I think the project becomes truly bankable once you understand when it fails. It can take several thousand of kind of continuous operating hours. And that's what matters for scale. And what we have seen repeatedly across many kind of startups we engaged with and we looked at is that, the process works very well under controlled conditions, but once you start moving to real world environment, things start breaking in. That's the angle actually where we come in as a technology partner, because once you have sufficient number of operating hours, you understand how your process works, what's your yield performance, what's your conversion, what's your energy efficiency. With the right tools like sensors, like PLCs, data infrastructure, the right models that we can help implement, you can actually model how the process or system will behave at a larger scale. And that's kind of the gap that we're bridging financially, but also with the help of solutions that Siemens can provide. And I think I just wanted to touch a little bit on a few other things that I think quite critical for this industry to succeed. One of them is around CapEx uncertainty. You mentioned cost. Obviously, cost is a major driver for this to be successful, but also CapEx. Lots of investors get sort of like rebuked by high capital intensity of lots of these projects. But I think what we see more is not so much capital, is uncertainty, whether it's going to be plus minus 15%, or what's going to be plus minus 100%. And again, it is directly linked with how much of a runtime you have, how much data, operational data you have. And again, this is something that can be modeled with the right kind of digital twin solutions. And the last kind of point I want to touch base on demand side, right? Lots of these SAF kind of projects, CO2 utilization projects, they got an early boost backed by policy incentives, quotas, net zero pledges, willingness to pay green premium. But again, what we're seeing, it goes back to your point, John, is that investors, industrial partners, they're scrutinizing these premiums now. They're scrutinizing whether this high headline offtake demand is going to be around if premiums compress, if the regulation policy incentives pushed back, reassessed. That kind of, on the one side, it drives innovation, but on the other side, it doesn't help also kind of innovation to some extent. And it's a bit challenging environment, I guess. And it's a bit of kind of, I think, chicken egg situation where we're in. There was lots of interest in synthetic fuels, but now with hydrogen kind of scale up, slowing down, the cost is still staying high. Electricity now being rerouted to data centers. What we're seeing is a bit of a pause now on all kind of these investments at the moment and waiting for EU refuel to be reassessed at 2027, because that's kind of the time when they will be reassessing the quotas. And there is an expectation that at least on e-SAF, there will be a bit of a pushback. But on the positive side, it's not linked to CO2 directly, but at least there are some breakthroughs on bio-SAF front. We've seen LanzaJet de-risking alcohol-to-jet technology, so there are lots of kind of positive things emerging.
Just to sort of follow on sort of semi-directly from that is like another area of risk, like that's not about like big demand, is actually like CO2. We keep talking about CO2 like it's this monolithic thing, and it is a single molecule, but like no two CO2 sources are the same. And something we worry about at our company is like, how do you take cement CO2, steel CO2, chemical CO2, DAC CO2? These are all going to behave differently with your technological solution. It's a huge risk if you're building a second plant or a third plant and you're massively changing your feedstock. It's not just security of supply. It's like, how do all these things behave? How does it change over time? If you have you build a CO2 to value plant, you have a 5-year contract with a CO2 supplier maybe? What happens if they change their mind and they go somewhere else? That's a huge risk. What if they change their process and their CO2 composition changes away from where you need it to be? That's another big difficulty, and there's actually no stability in this whole industry and this whole space to build from.
Yeah, that's a good point. CO2 purity, kind of a variable CO2 purity, is a big issue that even slight changes can have a significant impact on electrochemical processes, biological processes, yeah.
And another cautionary tale from the SAF space. Has anyone heard of UCO? Used cooking oil? So I remember meeting a guy at the start of sort of FICO Bloom. He used to work collecting oil from pubs. That was his thing. He would go around all the pubs in his local area. He'd collect their oil and he'd dispose of it for them. And they would pay him to do this. They would pay him like, I think, some $500 to $700 a ton. They would pay him to take it away and get rid of it. And then a few years later, someone discovered, hey, if you take used cooking oil and you blast it with the right kind of hydrogen and temperature, you can turn it into diesel. Great. And all of a sudden, his entire economics shifted. He was now paying the pubs. He was paying $800, $1,000 a ton to collect their oil because he was then selling it on as fuel. That value completely shifted. And the truth is, often when we hear conversations about CO2 to value, we treat CO2 like it is a waste resource. It is not a waste resource once you put steel in the ground. Once you have built a facility that relies on an input, you're paying for that. They can take it away and give it to someone else, or they can just not give it to you. There is no world where CO2 is free once you've built it. And I actually have this argument a lot of times with people who say they use sort of renewables. Oh, renewable energy will be free. We'll use it when there's ample renewable energy. There is no such thing as like ample renewable energy. There will always be a destination to send energy to. You will always have to pay for your energy because as soon as you've invested capex, as you say, you need inputs.
I wanted to know the guy who's paying people to take away the oil. If you have a better way to use that oil, isn't that like good?
No, it's very good. I just mean the economics of an industry can change. Oh yeah. It changes as soon as like we often hear when you hear like companies talk, they're like, oh, we found a waste resource, and that's free because it's a waste, but it's not a waste once you need it. It's a product.
Oh yeah. So you actually just add more value to your product. Probably know which one. I was gonna ask Alex to come onto stage and also share what you are doing with your e-fuel as well, but after the food.
I think with e-fuels there is an interesting kind of emerging trend around natural hydrogen. There's been a lot of hype around natural hydrogen. I think the US company Coloma, they had a very successful raise. I think it would be interesting, Alex, to hear your views on that. I understand that it's still very early days to say whether it can scale up hydrogen production, natural hydrogen production or not, but that could be a major kind of structural shift.
I'm actually really interested in your view on why hydrogen went from this growth industry that everyone saw these big curves, it's going to get cheaper and easier and there's so much demand. What has actually been that thing that has flipped the story and now hydrogen's not got that pull and push in the market?
I think it's mostly the cost. I think there was expectation that there will be significantly higher cost reduction than we're seeing now, even though there is lots of innovation driving electrolyzers costs down. But I think electricity is still a big kind of variable, and kind of rollout, scale up of data centers was a bit of an unexpected factor as well. So there is like a high competition for electrons now, for renewable electrons. So and also I think the investment appetite was not as high probably as it was expected previously. And I think to some extent it's been influenced by changes in the US policies. So it's like there is a combination of different factors that played into that.
I was just saying, I think there's been an underestimation of the cost of hydrogen transport. If you look at the UK now, really what's going ahead is the co-located production and use. And without that, the hydrogen market. I was at a natural hydrogen event last night, and they were talking about Namibia, and they were talking about the UK and Namibia. But how do you get your natural hydrogen to the UK? It's incredibly expensive. Do you turn it into ammonia? Incredibly expensive. Is it economical to do that if it isn't co-located? I struggle with that a little bit.
Yeah. And once those industries are more mature, that will be easier for them to sort of say, oh, it's going to cost, $3 a kilogram to move it versus $4 a kilogram to make it. And then you do that maths. But as you say, when those industries are that immature, then it's, what do you do? I know a hydrogen company that they got an off-take agreement. They were really happy because that sort of really worked for them. But the deal was you had to make it and sort out all the logistics. This massive company was going to had no insight and did not want to provide any support on getting it to them. They would pay a decent price for it, but all logistics was on this startup and it just couldn't do it, basically.
What do you think needs to change? I know we're talking about CO2, but on hydrogen, what do you think needs to change for hydrogen to get over the hump we're currently in?
Yeah, and hydrogen is obviously like a massive part of this discussion. Value means hydrocarbons, and half of hydrocarbons is hydrogen, so it's very related. I don't actually know. I don't know. I wasn't ever a big believer in like the hydrogen supply chain. I don't really understand why you take $10 of renewable energy and turn it into $4 of hydrogen, and that's a good business model. But I actually flip it on its head. My point is actually we currently subsidize fossil fuels. Fossil fuels are massively subsidized both through direct tax credits and because we allow fossil fuel users to use the air as a sewer. So making those price externalities real then makes the case for hydrogen and like renewable hydrocarbons much more appealing. But
there are a lot of founders in this room and also some operators. For example, Chushang used to work at Mission Zero, one of their first founding employees. And then Ariana is building another, also direct air capture to
That co-produces green hydrogen.
Also co-produce a green hydrogen company in the Netherlands, whose the company name is Brineworks. I've interviewed their co-founder on my podcast as well. I do want to have Alex to tell us about, I'm not asking you to give another TED Talk, but if you can just share like the story of how you started the company, and because you're in the e-fuel, right? Just for a one-on-one perspective, the difference between e-fuel and sustainable aviation fuel, are they the same, or how does the...
I'm founder of a company called CERT Systems. What we do is we have a CO2 electrolysis process that's integrated with capture, so we can capture CO2 and then convert it into chemicals. Specifically, we focus on the conversion of CO2 into ethylene, which is a good molecule for putting into existing uses such as plastics, textiles, but is also really useful for going into fuels such as kerosene or diesel through, again, existing processes that are used. So to your question about like SAF versus e-fuels, e-fuels tend to be anything that's made from CO2 and electricity. So it could be SAF, could be diesel, whereas SAF includes like the algae or bio base or used cooking oil, as long as it's sustainable.
Okay.
Sustainable. So that's kind of the difference. So there's
What
two
is
circles.
the difference between the economic inputs and output?
For SAF and
E-fuel.
For SAF and e-fuel. So I mean, it just depends on the route that you're taking, and so there's just kind of like a Venn diagram with two circles. Some of it is e-SAF if it's made from CO2 and electricity, but then you have different types of pathways to other sorts of SAF and different ways you can use CO2 and electricity to get to other fuels that are not for aviation.
Oh, thank you so much, and congrats again.
Thank you very much.
Yes.
Yeah.
Coming back to my planned voices in the room. Thank you so much for your contribution. I enjoy your breakfast. One last thing, maybe both of you can leave to the room when we go into the next conversation, next round of breakout, maybe from an investor perspective and from a founder operator perspective. What do you want them to think about in the next maybe 30 minutes or so?
Start with what's the non-negotiables. What has to happen in the world to make the CO2 to value chain real? I'd say one of those is like hydrogen, carbon capture, that kind of stuff. That's sort of has to be table stakes. How do we do that? Then the other is how these things work together. What's the competition? If there is going to be a massive CO2 to value industry, is likely going to be a lot of competition for CO2. Even if there's actually ample CO2, there's going to be some form of CO2 that is the highest value. It's going to be the cleanest, or it's going to be the most abundant, or the highest density. How do we actually manage that competition? Because at the moment, what we do is just say, oh, this product's more expensive. That can pay the premium for the premium CO2. But maybe that doesn't work when we're talking about a full-scale chemical industry or fuel industry. So yeah, it's how we value different values against each other.
If I can get a volunteer to do it together with me here. CO2, put it on the capital stack, and wrap it with insurance or protection, turn it into cash flow, and fist bump. Can you find another person on your table to do it together? Let's do it. Grab a ton of CO2, put it on the capital stack, wrap it with insurance or protection, and turn it into cash flow and fist bump. It's nice, right? I think it's like, because when we talk about finance and all of this stuff, it's very like kind of boring, for the people outside of climate or outside of finance or both. So this is a visual way of I want to bring more people into this. And when you're thinking about your next financing round, when you're thinking about talking to the investors, talking to the financiers, something to take it with you. And then we have the fruitful ending, which is we want to ask if anyone wants to share one piece of good news. Anyone? We need some good news like that. That's pretty.
So we work in public financing of climate technologies. We do a lot of work on large-scale funding opportunities. We've done a lot of EU Innovation Fund grants. I don't know if you all are familiar with EU Innovation Fund. It's a very large 40 billion euro fund, and I'd be adding to that. It's based off of the emission trading system revenues, and it funds large-scale, first-of-a-kind plants. So in the tens and sometimes hundreds of millions. In the last round, we worked on 2 multi-hundred million carbon or CO2 to value projects. And so these things are getting built at scale in Europe, and we've also financed some of them in the United States as well. So public financing is oftentimes absolutely critical to having these things actually deployed at any sort of commercial scale. But the financing does exist, and they are getting deployed in the world at large scale.
Amazing. Thank you so much. I think these are the news that I wanted to hear more. Does anyone from the startup front who wanted to share anything? No? Yeah, Trishan.
Hi. So my business essentially tries to connect the value chain from low technology readiness to high technology readiness. And we've just kind of signed the model effectively where I can take technology from an investor portfolio, engineer it properly, give it to an EPC, and then hand it off to a project developer. And we have a case study kind of going through that now, which is working. So the new model is landing, which is great news for me. So.
Thank you. Oh, yeah, you have to share.
Hi, everybody. I work at Brineworks. We're an electrochemical direct air capture company that co-produces green hydrogen. And our big news this year is very exciting. We had our 100-ton per year demonstration plant just launched 2 weeks ago. So it's feeling very fresh.
Yes. Let's make climate cool again.